Welcome to this explainer. Today we are tackling what is, honestly, the ultimate cosmic mystery. Why haven't we found aliens yet? I mean, we know the math, we understand the massive scales involved, so why does the universe seem so completely empty? We're going to break down the science, the probability, and some of the frankly terrifying philosophical theories behind this great cosmic silence.
Okay, let's dive into this with a number that is just incredibly hard for the human brain to actually process. 2 trillion. Recent studies suggest there are at least 2 trillion galaxies, not stars, galaxies, in the observable universe. And our own home, the Milky Way, contains up to 400 billion stars all by itself. When you're dealing with numbers this mind-bogglingly gigantic, the amount of star systems out there with potentially habitable planets is just too large to even wrap your head around. Pure mathematical probability dictates that the universe should be absolutely teeming with life.
Which brings us to a highly relatable, incredibly human question. Back in 1950, Enrico Fermi, who was a brilliant Nobel Prize-winning physicist and one of the architects of the atomic bomb, was having a casual lunch with some fellow scientists. They were just chatting about faster-than-light travel when Fermi suddenly blurted out, "But where is everybody?" Despite the sudden outburst, everyone at the table knew exactly what he meant. The sheer, overwhelming scale of the universe suggests intelligent aliens should literally be everywhere. So, why can't we see them?
To crack this case, think of this as our thrilling roadmap for today's cosmic investigation. We'll start with the crowded universe, move into the eerie silence, confront the great filter, examine the threats ahead of us, and finally ask, are we looking wrong?
Starting with Section 1, the crowded universe, and calculating those odds.
So, in 1961, an American astronomer named Frank Drake organized a meeting with 12 brilliant minds, including Carl Sagan, to discuss the search for extraterrestrial intelligence. But there was a slight catch. Drake had been so insanely busy organizing the event that he totally forgot to create an agenda. Scratching his head just days before everyone arrived, he frantically jotted down a calculation to estimate the number of intelligent civilizations in our galaxy. It's made up of 7 variables multiplied together, covering things from the rate of star formation to the fraction of planets that actually develop intelligent life. And you know what? That last-minute scramble gave the scientific community its first genuine framework for tackling this massive question.
And thanks to recent data from the Kepler space mission, we have a much better handle on some of those variables today. Just look at this number, 40 billion. That is the estimated number of Earth-sized planets orbiting sun-like stars right in the Goldilocks zone. You know, that exact perfect distance for liquid water to exist on the surface. And that is just in our Milky Way galaxy alone. That's 40 billion chances for life to catch hold right in our galactic neighborhood. Frank Drake and his colleagues eventually estimated there could be anywhere from 1,000 to 100 million detectable civilizations just knocking around out there.
Which leads us to Section 2, the eerie silence, otherwise known as the Fermi paradox.
And this brilliantly illustrates Fermi's underlying logic. We humans, Homo sapiens, have only been around for about 200,000 years. Meanwhile, modern crocodiles, they've survived for 85 million years, and certain sharks have been swimming around for 175 million years. Fermi reasoned that if a species can survive for millions of years, an advanced alien race should have had plenty of time, say just 10 million years, to thoroughly explore and populate the entire galaxy.
So we are left with this massive, direct contradiction. On one hand, the astronomical math basically guarantees a crowded universe. On the other hand, we have the terrifying reality of zero evidence. No signals, no visual proof, diddly squat. The SETI Institute has been searching for decades, and we hear absolutely nothing but complete, utter silence.
All right, Section 3, the Great Filter, the cosmic bottleneck.
Enter our primary suspect, the Great Filter. This theory suggests there is a highly improbable, deeply hidden evolutionary step where almost all life completely fails. Think of it like an incredibly steep, slippery staircase. Step 1 is abiogenesis, life sparking from non-living chemicals, like down in the hydrothermal vents of Earth's ancient oceans. That alone took 1 billion years. Step 2 is endosymbiosis. Billions of years ago, one single ancient cell absorbed another, creating a complex structure with a tiny power station we call mitochondria. This single-cell fusion was a freak accident that essentially only happened once, making it a wildly rare bottleneck. And step 3? Well, that's achieving high intelligence.
Because here's the thing, high intelligence is not some inevitable evolutionary guarantee. It is a massive, incredibly expensive biological gamble.
The human brain makes up only about 2% of our body weight, but it completely hogs a staggering 20% of our energy. For a species to naturally select for a trait that drains that much energy, the environmental and social conditions have to be absolutely perfectly aligned. Basically, high intelligence is a super rare evolutionary anomaly.
Which brings us to this incredibly dramatic psychological pivot. We really have to ask ourselves, is the great filter behind us or is it ahead of us? If it's behind us, meaning the hardest possible steps were those early cellular mutations, then humanity has already beaten the impossible cosmic odds. We might actually be one of the only intelligent species in the entire universe. But if that filter is still ahead of us, well, that means we might be cruising directly toward our own destruction. And that shifts us to Section 4, Threats Ahead of Us, the real burden of intelligence.
If this great filter is indeed ahead of us, what exactly does it look like? Well, here's some observed extinction-level bottlenecks that could stop any civilization right in its tracks. First, there's unregulated artificial intelligence. If AI becomes fully autonomous and coldly decides humans are a problem, it completely lacks any natural emotion or remorse. Then there's the famous gray goose scenario, nanobots replicating entirely out of control and consuming all matter on a planet. We also face climate collapse, a brutal chain reaction where rising temperatures release trapped methane, triggering an unstoppable environmental breakdown. And of course, good old nuclear annihilation. It turns out a civilization's technological tools grow at lightning speed, but its moral understanding and collective common sense simply cannot keep pace.
Just to put that dangerous tension into perspective, consider this number. The Tsar Bomba, which was detonated during the Cold War, produced an explosion 3,300 times more powerful than the bomb dropped on Hiroshima. 3,300 times! This perfectly, objectively, captures the natural tension between advancing technology and a civilization's built-in capacity for self-destruction. At our current technological level, we are just vastly more capable of wiping ourselves out of existence than we are of actually populating the galaxy. Let's move to our final phase, Section 5. Are we looking wrong? Alternative solutions.
Let's move to and see how this builds our understanding of the universe with a few fascinating alternative theories. Maybe there is no filter. First up is the zoo hypothesis. This is the idea that aliens are basically treating Earth like a protected cosmic nature reserve. They're deliberately observing us without interfering, just letting us develop naturally. Second, there's the tech mismatch. We are obsessively listening for radio waves, right? But an advanced civilization might have completely abandoned radio technology millions of years ago. I mean, think about it. Dolphins have been intelligent for 20 million years, and they certainly haven't built a radio telescope. And finally, the most terrifying theory of all, the super predator. The dark idea that a single, massively advanced civilization is out there, systematically wiping out any emerging competition before they can become a threat.
On top of all that, there is a massive practical problem here: the sheer distance of space and the speed of light. Let's say a curious alien in Andromeda, which is our nearest major galaxy, pointed a super powerful telescope directly at Earth right this very second. They wouldn't see you and me. Because Andromeda is 2.5 million light-years away, they would see Earth exactly as it was 2.5 million years ago, long before modern humans existed and way before we started blasting radio waves into space. The universe is simply so vast that timing a mutual hello is nearly impossible.
So, the crucial point is, maybe the silence is actually a good thing. As the brilliant Stephen Hawking warned, actively blasting signals into the dark universe might be a dangerously naive idea. If a super predator civilization does exist, the absolute last thing we want to do is shout, "Hey, here we are," into the cosmic void. Older, wiser civilizations might be staying quiet on purpose, because they know that survival out there means staying hidden.
Ultimately, the Fermi paradox forces us to take a really hard look in the mirror. Whether the universe is a dark forest filled with hidden predators, or whether we are entirely alone, having miraculously survived the great filter of evolution, the next step is entirely up to us. As our technology rapidly outpaces our biology, we have to ask ourselves a pretty tough question. Can humanity actually unite, overcome our inherent self-destructive tendencies, and prove that we have what it takes to survive our own intelligence? Or will we just be another silent, extinct ghost town in a very crowded universe? Thank you for exploring this cosmic explainer with me today, and as always, keep questioning everything.